Good day, friends. I hope you're all doing fine. Today we are having another section from chapter 2, the second section. As you know, previously in chapter 5, section 1, we talked about integration. Let me give a quick review. What was integration? Integration, we said it is the anti-differentiation. That means we are like thinking backwards. The derivative of the function is given to us. We have to find the original function that has been differentiated. In general, we said we are calling this anti-differentiation as integration. We had some rules for integration. If you are given a function, how do we integrate that function? The first one was a constant rule, k dx. We said whatever we have, it will come out as kx plus c. If you have got integration of x to the power of n dx, we have got a power, then we will add, we will increase the power by 1, okay, plus a constant number. Okay, we said this is called the family of antiderivatives when you're adding that c next to it. And then we came to another one. We had integration of e to the power of k x dx. What is the integration of this? That will be 1 over k e to the power of kx plus c. Of course, the n that we have got from the power must not equal to -1 because -1 gives me something undefined. So what will be the case when n is equal to -1? 1 over x dx. That will be ln of absolute value of x plus c. So these were the rules that we studied in the first section. Okay, we know if you have got the properties of constant multiple rule, if a constant is multiplied to a function, if we have got summation of two functions to be integrated, it is distributed over them. Let us do an example. If you have got, for example, x plus 2, that will be a simple example just for reminding. Since there is addition between them, so this integration is for the x and for the 2. So what is integration of x? That will be x squared over 2, and the integration of 2 is 2x, and all plus c. Okay, of course, if you have got minus, here would have been changed into a minus. But we do not have anything like that. If it is, for example, 2x dx, that's not equal to integration of 2 dx multiplied to integration of x dx. We do not have something like that. So integration is not distributed over multiplication. This is constant multiple rule. The constant comes out, okay? This one is changed to integration of 2 dx, okay? And that could be solved easily. But when you have got this one, it is distributed over the addition sign. Now, today we are coming to integration by substitution. If you have got cases that does not include these ones, it looks like those, but instead, for example, having x to the power of n, if I have got, for example, 2x plus 1 all to the power of n, what will happen? How can I do that integration? For example, instead of having root of x, if I have got root of, for example, 5x plus 5, what will happen? How can I solve this one? We are using integration by substitution. Okay, now let's see what is integration by substitution. I will do an example together while writing the steps of the substitution, okay? The first thing, let me write it, of course, substitution method. Okay. What do we have in substitution method? The first step that we have got is to choose a substitution, okay? Choose a substitution. That means instead of having x, in general, of course, the function will be given you in terms of x, but we have to change the integration. Instead of having x, we are changing it to something else. For example, we are letting, okay, u is equal to something. Okay, of course, in the course material, it's written in another way, but I will explain it for you, like to make it easier for you and to make you understand better. Okay, so we are letting u is equal to something else. That something else, we will choose it from the integration, and later, of course, when we are doing the examples, you will be familiar with that substitution. Step 2, where students always forget to do that step, and it is an important step. If you will not do that step, you cannot keep going on and do the solution for the integration. Find du. Okay, find du. What is du? Du is the derivative of u. What is that u? It is that u. Okay, you have first, you're given a function, an integration, you are letting u is equal to something. Okay, and then when you're finding that u, you have to find the derivative of that u. That's very important for you, because if you're not doing that one, you cannot do the solution or finding the integration. Okay, the third step, express the integral, the entire integral, the integral that's given to us, in terms of u du. Okay, so the integral that it is given to us, it is in terms of x dx, t dt, doesn't make a difference the value. But when you are changing u, when you are letting u, finding du, we are changing everything that we have got in the integration from x to u. Okay, that's what we are going to do to solve the complicated integration that is given to you. So how will we represent it? It's given to us f of x dx. I'm changing it to something as g of u, because the function will change from x to u, because we are substituting u inside it, and du. Okay, then the fourth step, solve step 3. Okay, we are solving that step. That means we are solving, okay, I will write it here, solve integration of gu du. We change the x to u, and then when we are getting u du, we will solve this one. 5, replace, when you are solving it, of course you will get a solution. Replace u back to x. Okay, it's of course written in other terms, but I'm writing it like that so that it will be obvious for you. When we are solving the integration gu du, you will get a function of u. Okay, you will get a function in terms of u, but the integration that is given to us, it's in terms of x, so we have to change back those u to the x's that were previously substituted. Let's give an example. We have got example 5.2.1. okay, in that example, it is required from us to find integration of 2x plus 7 under the square root dx. Okay, it is given to us to find this integration. Before solving that one, let me remind you of the integration of root of x dx. How were we solving that equation? I mean that integration. We were changing this one to x to the power of 1 over 2 dx. We were changing it to a power function, okay, to a power x to the power of something. And we know that if we have got x to the power of n, how can we solve this one? That will be x to the power of 1 over 2 plus 1 over 1 over 2 plus 1. The power is increased by 1 over the number that is in the power, all plus c. So that one is equal to what? X to the power of 3 over 2 all over 3 over 2 plus c. If I rearrange this one, that will be 2 over 3, and that will be x to the power of 3 under the square root all plus c. That was previously solving was like that. But now instead of that x, what do I have? I have got a bunch of things inside the square root. So I have to make this one simple so that I can understand, so that I will put it in a way that is simple like this one and I can solve it. So what shall I do? I'm putting this part, okay, I'm putting this part as u, okay. Why? To get something simple like this one and solvable, because if you cannot do it like that, You cannot solve it easily because there is something complicated here. Of course, for you it's complicated. You have got something complicated here and you have got something simple here that you can solve it directly. So I'm changing that complicated thing to something simple. So what shall I say? I will say, look, the first step, it says choose a substitution. You have to know which part you are putting as a substitution. So we are letting u is equal to 2x plus 7. That's step 1. Look, choose a substitution. We let u into something. What is that thing? It changes from example to example. But if you are solving a bunch of examples for yourself, you will be familiar with the forms that you will set for u. Okay? Now that's first step. We chose a substitution. We let u to equal to 2x plus 7 so that we can make the integration easier. The second step is to find du. That means the derivative of u. What is the derivative of u? I will write du, derivative of u is equal to, what is the derivative of this part? Derivative of 2x is equal to 2 plus 0. So it is 2. But I took the derivative of this side with respect to x. Okay, I took the derivative of this side with respect to u, so I will write du. That's equal to the derivative of this side. I took it with respect to x, so I will write 2 dx. Okay, now we did first step, we did second step. Now I have to change the integration. Okay, I have to change that integration into terms of u. Okay, why am I changing it? To make it simpler. I take away all of the x's and put u's instead of that. So when I'm transforming the integration symbol is still there. Okay, the square root is still there, but instead of writing 2x plus 7, okay, what will I write? I will write u because I have changed 2x plus 7 into u. Now, instead of dx, of course, you're changing this x. I have to also change that dx into something u because I have changed the integration to something having u in it. There is no x. There must be no x inside that integration because I'm changing whatever x is in here into u in here. Okay, that's called the transformation of the integration from x to u, substitution method. Okay, so how can I change this one? I know from this one, okay, that 1 over 2 du is equal to dx. Look, what did I do? I need dx alone. Okay, I need this one alone. So what did I do? I divided both sides by 2. Okay, when I divide both sides by 2, that will be 1 over 2. Okay, 1 over 2 du, that's equal to dx. Now what is dx equal to? If you look at it, dx is equal to 1 over 2 du. Now, if you look, I transformed the integration that is given to me into an integration that's in forms of u du. Let us solve this one. This one looks simpler than that one. So I'm taking this 1 over 2 is a constant. I will take it out. Okay? Integration of square root of u du. Now, do you know this integration? Yes, it is the same, exactly the same as this one, but instead of x, I have got u. So I will solve it the same way. 1 over 2, integration of u to the power of 1 over 2 du. Okay, look, the integration became something simple. When it becomes simple, I'm doing it the original way. Okay, now I have got this. Okay, integration of this one. So that one is equal to what? That's equal to 1 over 2 u to the power of 1 over 2 plus 1 all over 1 over 2 plus 1 all plus c. I've solved it. Okay, like this one we did, like we did for dx, we are doing the same procedure for u. So that's equal to what? 1 over 2 u to the power of 3 over 2 over 3 over 2 plus c. That's equal to what? 1 over 2 multiplied to 2 over 3 because this one goes up and becomes upside down. U to the power of 3 under the square root because I will change this one back to the root plus c. Now this is the let me simplify it one more step. That will be 1 over 3 integration of, square root of u to the power of 3 plus c. Now we solved the integration in terms of u. But what is given to me? The integration is given to me in terms of x. So I want the result to be something in x. How can I change this u back to x? It is easy. That will be 1 over 3 square root of, instead of u, what do I have? I have put u is equal to 2x plus 7. Okay, so 2x plus 7 all to the power of 3 plus c. Okay, look what we did. We did the substitution method to make it simpler, the integration. Then when the integration became something simple, we did it like the previous steps we did last section. Then when we are solving it in terms of u, we will get our result. When we are replacing that u back to the x that we have substituted, then we will get the result for the integration that is required from us, and that is the result. Okay, now we are coming to another example. If you know how to do the substitution, I think everything will be easy for you to find. It says again, find integration of 8x multiplied to 4x squared minus 3 all to the power of 5 dx. Okay, let me remind you of the previous lecture. If you have, we had, for example, integration of x to the power of 5 dx. How were we dealing with this one, solving it? That will be x to the power of 6 over 6 plus c. Okay, that was a power function. But now here, what do we have? I have got, instead of x to the power of 5, I have got 4x squared minus 3 all to the power of 5. So I have got something complicated here. Instead of having x to the power of 5, I have got that bunch of things to the power of 5. So I'm putting that bunch of things like we did in here. Look, instead of having x, I had a bunch of things to the power of 1 over 2. We let this one equal to u. So to choose the substitution, I'm letting this bunch of things, let u equal to 4x squared minus 3. Okay, this is the first step that we have to do. Choose a substitution u. Then we have to find du. Okay, now when we are finding du, that means the derivative of u. What is the derivative equal to? That's equal to 8x. We took the derivative of this one as with respect to x. So this is u, this is the derivative of u. Then what do we have to do? We have to change the integration in terms of u. We are changing the x's that we have got into something of u. So that integration is equal to, okay, let's first look at this one. Instead of 4x to the power of 2 minus 3, I have got what? I have got u. So that will be u to the power of 5. Okay, instead of that bunch of things, I have got u. So I will write u to the power of 5. What remains here? This part remains here. Okay, 8x dx remains. If you look at this part, 8x dx is equal to what? Is equal to du, because we have to change whatever x is in that step to u du. Okay, so for x to the power of 2 minus 3 is u to the power of 5, and instead of 8x dx, because this part is remained, these two together sums up, becomes du. So if you look at this one, u to the power of 5 is the same thing as x to the power of 5. So that will be easy. It will be u to the power of 6 over 6 plus c. Okay, now we solved the integration. Look, the integration is gone. Why? Because we solved it. It became u to the power of 6 over 6 plus c. But the integration is given to us in terms of x, so the result must be something in x. So I'm changing that u into x. How can I change it? I've already changed the x to u with respect to that substitution. So I'm looking back at the substitution. Instead of u, what shall I write? I shall write 4x squared minus 3, okay, all to the power of 6 plus c all over 6. And that is the solution for the integration. Look, it became so easy that we could solve it only in a step. Okay, we have got another example. The example is given as 5.2.3. Again, it says find integration of x to the power of 3 e to the power of x to the power of 4 plus 2 all dx. Okay, now previously, let's go to the previous section. Okay, I'm writing that examples here so that you can compare between the previous section and this section, and how can you do the substitution. Okay, in the previous section we had e to the power of, for example, kx dx. Okay, what was that equal to? That would have been 1 over k e to the power of kx dx. Look, the x was something simple here. Okay, but now instead of something simple, what do I have? Again, I have got bunch of things. So again, the substitution will be the power. Okay, so we are letting u equal to x to the power of 4 plus 2. Okay, x to the power of 4 plus 2. After u, what shall we find? We shall find du, the derivative of the function that I have made the substitution. X to the power of 4 is equal to what? Is equal to 4 x to the power of 3 plus 0, so I will write simply dx here. Okay, now what do we have to do after setting u and du? I have to change the integration from x to u du, so that integration will equal to e to the power of, look, I'm not looking at this first, I'm looking at the substitution where I have made the substitution, e to the power of, what did we call the bunch of things? We called it u, so e to the power of u. Now I changed this part. Okay, I changed the e. Okay, what do I have to do second, the other step? Look, I changed this part. What's remained in here? This part is remained. X to the power of 3 dx is remained here. How can I change this one to u? Because there must be no x in the new integration. So I will look at the dx because dx is present in here. So I'm looking at this part. I know that 4x to the power of 3 dx is equal to du. What's extra here? 4 is extra. So I'm dividing both sides by 4. Okay, so that I get x to the power of 3 dx and I can do the transformation. So this one will change to what? This step, it will change to 1 over 4 du is equal to x to the power of 3 dx. Now x to the power of 3 dx changed to what? Changed to 1 over 4 du. Okay, that's 4. That's 4 because students always mix up with the u. Okay. Now, what is that? That is an easy question. I will take 1 over 4 out. Integration of e to the power of u du. Okay, that's 4. Now, e to the power of u, what's the integration of it? That will equal to 1 over 4. I will write it as it is. E to the power of u is again e to the power of u. We know this one. Plus c. Okay, because I know that this integration is equal to that. Now I solved the integration in terms of u, but I have to change it back to what? To x. And I know that that will be 1 over 4 e to the power of, instead of u, what shall I write? X to the power of 4, okay, plus 2 and all plus c, and that is the required result. Okay, we have got another example. Of course, each example, if you've seen from the examples, each one of them has got we are substituting something else, not every time what is inside the power. Okay, that's why we are doing those examples, because they are different from each other. Again, what's required from us to find integration of this one is a little bit different from the others, needs more steps and to concentrate more. Here we have got x over x minus 1. When we are having denominator and numerator, in general, when you see something complicated here, set the denominator equal to u. Okay, in general, look, I'm not saying in every example, I'm saying in general, put the denominator into something equal to u. So let u equal to x minus 1. After u, what shall I find directly? The derivative of u. What's the derivative of x? That's equal to 1, so 1 dx. Okay, now I have to change the integration. I'm doing it here so that you see it. Okay, I'm not going to the other page. That's equal to what? Integration of, instead of x, or let me not talk about the x first. Okay, I will talk about it later. Instead of x minus 1, what shall I write? I shall write u. Instead of dx, look, dx is remained here. Okay, what shall I write? I shall write du, because dx is equal to du. How about that x over there? Okay, what can I write instead of that x here? I have got here u is equal to x minus 1. So I'm changing this one. I'll take the 1 to the other side. That will be u plus 1 is equal to x. So instead of that x in here, I'm writing u plus 1. Look, here we had two transformations. We first transformed this one into u, dx is equal to du, but also I have left x here. So instead of, I cannot of course write x here because that will be a mixture between u and x, and that will make a problem here, cannot solve the integration. So instead of that x, what shall I write? I'm looking at the substitution, taking the 1 to the other side, and I will find x, and I know that x is equal to u plus 1. If you look at that integration, I can write this one as u over u, okay, plus 1 over u, all du. Is that fine? I distributed this one for this and that. You know, if I have got a plus b over c, that's equal to a plus a over c plus b over c. Okay, now this one I can write it as what? As integration of 1 plus 1 over u du. Okay, this one changed to 1, and that one is 1 over u du. What is integration of 1? That's equal to u. Don't say x, because here we are taking the integration instead of u. I mean in terms of u, not x. So I'm saying that 1 is equal to du. Okay, I mean it's equal to u because we are taking the integration with respect to u. Plus, what is 1 over u? Okay, you know that if I have got 1 over x, okay, integration of 1 over x is equal to what? Is equal to ln of absolute value of x plus c. But here I have got u, so that one will equal to ln of absolute value of u plus c. Now we solved the integration in terms of u. I have to change it back to x. U is equal to what? Is equal to x minus 1 plus ln of x minus 1, I mean that's an absolute value, okay, x minus 1 and all plus c, and that is the required result. Okay, we've got another example, example 5.2.6. again, find integration of ln of x all to the power of 2 over x dx. Okay, now if you look at this one, we have got ln of x, okay, inside the I mean underneath the power of 2. I've got a bunch of things to the power of 2, so I will let u as ln of x. Okay, so let u equal to ln of x. After the u, what shall we find? We have to find du. That will be 1 over x dx. Now we found u and du. What do we have to do? We have to change the integration from x to u. So that one is equal to what? Or let me first simplify this one. I will write it in another way, not simplifying it. Can I write this one as ln of x squared multiplied to 1 over x dx? Okay, why? Because when I'm multiplying this one to the 1, I will again get ln of x squared over x. So it's the same result, but I'm writing it like that in a simplified form so that I can change the integration from x to u simpler. Okay, what is ln of x to the power of 2? That is u to the power of 2. Okay, what is remained here? 1 over x dx is remained here. Okay, here I have got 1 over x dx. 1 over x dx is equal to what when I'm changing it in terms of u? That will be du. Now I have got this one. It's an easy integration. It is like integration of x squared dx. X squared dx is equal to what? X to the power of 3 over 3 plus c. Okay, that integration is the same thing as this one, but in terms of x. Okay, so that one is equal to u to the power of 3 over 3 plus c. I have to change the u back to x. So u is equal to what? Ln of x to the power of 3 all over 3 plus c. And that's the required result, and very easy. We are given another example. 5.2.7. Again, find integration of e to the power of 5x plus 2 dx. Again, we know that if you have got integration of e to the power of x dx, how can I solve it? That will be e to the power of x plus c. But instead of x, what do I have? Again, I have got a bunch of things. So I'm letting that bunch, okay, equal to 5x plus 2. Again, we are finding the derivative of this one. And when we are finding the derivative of this one, I have to change the integration that I have got into u du. So that one is integration of e. Instead of the bunch, I will write u, okay? And instead of dx, what do I have here? I have to divide both sides by 5 so that I get dx alone. That will be 1 over 5 du is equal to dx. So that one is equal to 1 over 5 du. That integration is equal to what? That's equal to 1 over 5 e to the power of u plus c. I have to change that u back to x, so that will be 1 over 5 e to the power of 5x plus 2 all plus c. That's easy. Now, we are moving to another example. That would be the last example, I think, you would have in the course. I mean, in that section. We have got example 5.2.10. It says evaluate integration of x to the power of 4 e to the power x to the power of 4 plus 2 dx. Look at that one. In this example, we did this one previously. It was, look, the difference between this one and that one. Here I have got x to the power of 4 plus 2. Next to it is a power less than 4. Okay? It's a power less than 4. But here, if you look at this one, x to the power of 4, and next to it, it is to the power of 4. In such situations, for you, this one has got no solution. In mathematics, it has got solution. But for you, depending on substitution method, it has got no solution. Okay, so how can I solve an equation, I mean an integration that is that involves e to the power of x to the power of something? That power here must be 1 less than there. Okay, so if I have got integration of x here, 1 less, okay, e to the power of x to the power of, okay, plus or minus something. So what do I have? If I have got e to the power of x to the power of anything, that one must be 1 less than this power, then I can solve it. So if I have got integration of x to the power of 2 e to the power of x to the power of 4 plus 2 dx, can I solve this one by substitution method? No, I cannot solve it. Why? Because that power is 2 less than, okay? That's 2 less, so that has got no solution for you. Okay, if I have got integration of x to the power of 5 e to the power of x to the power of 4 plus 2 dx, can I solve this one? Again, this one has got no solution. Why? Because this power is one more, okay, than that power. So the only case that you can solve it by substitution method is one less. Look, we in that example, we had the power was 1 less than x to the power of 4, then we solved it. Or else we cannot solve integrations involving e with a power less than, more than, anything else except 1 less than the given power of e to the power of x. So in general, if we summarize it, what did we have? We set, if you have got square root, we are setting whatever underneath the square root as u, okay? If you have got something over another thing, okay, if you have got a fraction, we are setting the denominator into u, okay? If you have got e to the power of something, we were setting that one into u, okay? And if we have got, that's the first case, okay, 2, 3. And if you have got a bracket to the power of something, we will set that bit into u. Okay, so in general, those are the cases that you have got in here, although it may be different in other examples, but in general, the things that are under the square root, you will let it as u, that will be the substitution. The things in the denominator will be the substitution, power of e, and anything under the power. Okay, for example, if you have got 2x plus 3 all to the power of 5, we are letting 2x plus 3 as the substitution. Okay, that's all for that section. Hope you will understand it. Any questions, I will be available. Have a nice time and bye-bye.